We continue our discussion on Bernoulli's theorem. We derived the equation, Bernoulli's equation, like as P plus half rho V square plus rho GH is a constant. This is for an ideal fluid which is flowing in a pipeline. The pressure energy, the kinetic energy, and the potential energy are constant. And if I look at two cross sections, then I get the form P1 plus half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho GH2. Now, I want to discuss a couple of points in this video. The first point that I want to discuss is if we have a horizontal pipe. So, for a horizontal pipe, right, H1 will be equal to H2, right, because the pipe will have both the points, both the cross section will be at the same height from the reference point, and therefore H1 will be equal to H2, and therefore the Bernoulli's equation will take the form P1 plus half rho V1 square is equal to P2 plus half rho V2 square, because these two quantities, rho GH1 and rho GH2, will be equal. Therefore they will get cancelled out, and we will get P plus half rho V1 square is equal to P2 plus half rho V2 square, which can be written as P plus half rho V square is equal to constant, right, for horizontal pipe. Okay, that's one thing. And the second thing I want to discuss is one of the conclusions from Bernoulli's equation. If you look at this equation, P plus half rho V square plus rho GH is equal to constant, we can see that if the pressure of the liquid increases, the velocity of the liquid has to decrease to keep this quantity constant. So one of the conclusions is that if velocity of the liquid increases, velocity increases, pressure decreases. Right. That means, supposing you have a pipeline which is something like this, right, something like this, then here the area is larger. This is A1, this area is smaller, A2. So what will happen is the V2 and V2 will be larger than V1, right, because the area is decreasing by equation of continuity. And if V2 is greater than V1, then by Bernoulli's theorem it will also mean that P2 will be less than P1. The pressure of liquid over here will be less than over here. Now you may find this a bit difficult to kind of understand, but please note that the pressure that we are talking about over here is the internal pressure of the liquid, right? You know that liquids, if I look at this particular area, the liquids move in random directions, right? They move in different directions, right? And they apply force onto the walls. They also collide with each other. The pressure which is generated because of that, we are referring to that pressure. We are not referring to the pressure that is generated because of the movement of the water. We are talking about internal pressure of the liquid. And in some ways what happens is when the liquid starts moving faster, right, the molecules of the liquid, a larger part of the molecules move in the direction of the liquid, and therefore the cross movement kind of decreases, right, and hence the pressure decreases. So V2 is greater than V1 would mean P2 is less than P1, and that is because P2, P1, the pressure that we are talking about here is the internal pressure of the liquid. That is point number 2 I wanted to discuss. The point number 3 that I want to discuss is that what happens, right? What would happen in case of or I want to let me begin by discussing heads, right? Okay, in physics, heads means height above a certain level. Supposing you have a let's say this is the ground level, and there's a pipeline over here, right, there's a pipeline over here, and this filled with water, right, and this height is, say, let us say h. Then this height of water, or this column of water which is above the earth level, it is known as head, right? So head of h meters, head of h meters, right? So if I look at Bernoulli's theorem again, if I p plus half rho v square plus rho gh is equal to constant. And if I divide this equation by rho g throughout, so this is divided by rho g, this is divided by rho g, and divided by rho g, then I'll get p upon rho g plus v square upon 2g plus rho will get cancelled, so h is equal to constant. Now if I find out the units of these three terms, right, it will turn out to be meter, it will turn out to be distance, right? Let us take an example. Let us take v square upon 2g. So the unit of v square will be meter per second into meter per second, and the unit of g is meter per second square. So second square, second cancel, meter cancel, I am left with meter. So this term is a measure of length, right? Similarly, if I take pressure upon rho g, I'll again get length, right? Pressure is Newton per meter square, density is kg per meter cube, and g will be meter per second square, right? So this will come down to meter square meter case, this goes. Now Newton is kg meter per second square. I have kg over here and second square over here, second square gone, kg gone, I'm left with meter. Right? So this is meter, this is also a unit of meter, and this is also meter. So all these three terms are nothing but they represent energy in terms of height, and that height is known as